Finally, let us see the composition and structure of the atmosphere. First, let us see the composition of the atmosphere. The atmosphere can be described as, I quote, a blanket, unquote, of air surrounding the earth. This mixture of gases contains huge number of solid and liquid particles. Two gases, nitrogen and oxygen, make up 99% of the air. Other gases constitute about 1%. At sea level, following gases comprise the air: nitrogen, oxygen, carbon dioxide, neon, helium, ozone, hydrogen, krypton, xenon and methane. Besides, large number of water vapor and dust particles are also present. Of all these gases, oxygen happens to be the most important, which is so essential to all life forms. The following table gives the composition of the air. All living organisms inhale oxygen. It is essential for most combustion. When any substance burns, oxygen is consumed. Nitrogen is another gas which about 78% of the atmosphere's volume is made up of. Its main function is to regulate combustion by diluting oxygen. The third important gas is the carbon dioxide, which is the product of combustion, constitutes only about 0.03%. Being an efficient absorber of heat from the upper atmosphere and considered to be of great climatic significance. Despite of the fact that portion of carbon dioxide is relatively constant, its percentage is gradually rising. It is estimated that from 1890 to 1970, the content of carbon dioxide has increased more than 10 times. This is a matter of great concern to all of us. Let us see the structure of the atmosphere. The Earth's atmosphere has 5 primary layers, referred to as spheres. From the lowest to the highest layer, they are the troposphere, stratosphere, mesosphere, thermosphere and the exosphere. The 4 boundaries between the primary layers, referred to as passes, are the tropopause, the stratopause, the mesopause and the thermopause. Let us see these passes in more in detail. Troposphere. The troposphere is the lowest and thinnest layer of the atmosphere and extends from the Earth's surface to about 7 kilometers high at the north and south pole and 17 kilometers high at the equator. This is where we live. As the density of the air in this layer decreases with height, the air temperature in the atmosphere also decreases with height. The temperature drops from about 14 to 15 degrees Celsius at the surface to about minus 45 degrees Celsius at the top of the atmosphere. All of our weather occurs in the troposphere. Almost all clouds and precipitation from the troposphere, weather fronts, hurricanes, thunderstorms are tropospheric phenomena. The troposphere contains about 80% of the total mass of the atmosphere. In fact, 50% of the total mass of the atmosphere is located in the lowest 5 to 6 kilometers of the atmosphere. Tropopause. The boundary between the troposphere and the stratosphere is the tropopause. Together, the troposphere and the tropopause are known as the lower atmosphere. The stratosphere. From the Latin word stratus, meaning spreading out. The stratosphere extends from the tropopause height of 7 to 17 kilometers to a height of about 50 kilometers and contains about 19% of the atmospheric gases. The stratosphere experiences increasing temperature, solar radiation with height. It contains the ozone layer because the solar radiation is increasingly absorbed by oxygen molecules in the stratosphere, leading to the formation of ozone. The ozone layer resides in the lower portion of the atmosphere, though the thickness of the layer varies seasonally and geographically. The temperature usually stops decreasing. It becomes roughly constant at first and then begins to increase with height. The air in the stratosphere is very dry, generally having less than 0.05% of the maximum amount of water vapor found near the ground. Clouds are very rare here except for occasional thunderstorm penetration in the lower part. The temperature increases in the stratosphere because of the presence of ozone. Ozone's absorption of ultraviolet radiation leads to warmer air that can sometimes reach temperatures as high as those found at the ground. Stratopause. The boundary between the stratosphere and the mesosphere is the stratopause. This atmospheric pressure here is about 1 by 1,000th of the atmospheric pressure at sea level. What is mesosphere? From the Greek word meso meaning middle. The mesosphere extends from stratosphere's height of about 50 kilometers at a height of about 80 to 85 kilometers. The gases continue to become less and less dense with height. As such, the effect of the warming by ultraviolet radiation also becomes less and less, leading to a decrease in temperature with height. On average, temperature decreases to as low as minus 100 degrees Celsius at mesopause. Mesopause. The boundary between mesosphere and the thermosphere is the mesopause. It is the coldest place on the earth with the temperature as low as minus 120 degrees Celsius at times. Let us see the thermosphere. The thermosphere extends from the mesopause height of about 80 to 85 kilometers at a height of between 500 to 1000 kilometers and is referred to as the upper atmosphere. The gases of the thermosphere are increasingly less dense than in the mesosphere. As such, increasing high energy ultraviolet and X-ray radiation from the sun absorbs by the molecules in this layer results in the temperature increasing to as high as 2000 degrees Celsius near the top of the layer. However, despite the high temperature, this layer of the atmosphere would still feel very cold to our skin because of the extremely low density of the air. The total amount of energy from the very few molecules in this layer is not enough to heat our skin. Thermopause. The boundary between the thermosphere and the exosphere is the thermopause. Extends from the tropopause height of 500 to 1000 kilometers up to a height of 10,000 kilometers above the Earth's surface. The exosphere is the outermost layer of the atmosphere, and it is in this layer that our man-made satellites orbit the Earth. The density of the exosphere is so low that particles within it do not collide. As a result, particles in the exosphere can escape altogether from Earth's atmosphere into the space. There are two other regions of the atmosphere that deserve discussion. One is the ionosphere and the other is the ozone layer. Ionosphere. Solar radiation causes ionization of the molecules in a region of the atmosphere that extends from about 50 kilometers up to about 1100 kilometers above the earth. That region is called the ionosphere, and the most of it is in the thermosphere, although it overlaps into the exosphere and above the thermosphere and the mesosphere below the thermosphere. It is of importance because certain regions of the ionosphere make long distance radio communication possible by reflecting the radio wave back to the earth. Ozone layer, though part of the stratosphere, the physical and chemical composition of the ozone layer is far different from that of the atmosphere. Ozone O3 is the Earth's atmosphere is created by ultraviolet light striking oxygen molecules containing two oxygen atoms O2, splitting them into individual oxygen atoms. The atomic oxygen then combines with unbroken oxygen to create O3, the ozone. Ozone is unstable, and when ultraviolet light hits ozone, it splits into a molecule of O2 and an atom of atomic oxygen, thus creating a continuing process called the ozone oxygen cycle. This occurs in the ozone layer, the region from about 10 to 15 kilometers above Earth's surface. About 90% of the ozone in the Earth's atmosphere is contained in the stratosphere. Ozone concentrations are greatest between the highest of about 20 to 40 kilometers above the Earth's surface, where the range from about 2 to 8 parts per million by volume. Summary and conclusion. Weather is the instantaneous state of the atmosphere or the sequence of the state of the atmosphere as time passes. As we know, the behavior of the atmosphere at a given place can be described with number of quantities characterizing the physical state of the air, such as the temperature, pressure, water content, motion, etc. The temperature, pressure, wind, precipitation interact with each other. The influence of atmospheric conditions like the direction and velocity of the wind, amount of insolation, cloud cover, and the amount of precipitation will greatly affect the weather and climate of a region. The influence of these elements differ from place to place and time to time. Temperature being a very dominant factor in determining the weather and which varies greatly with altitude, there is a need to understand the atmospheric zones, and the properties consist of temperature, density, pressure, and chemical and electrical properties of these layers. They affect the incoming solar radiation and the heat budget of the atmosphere. In the next episode, we will be discussing on the factors affecting the distribution of insolation and the heat budget.